M.S. Ramaiah University of Applied Sciences.
Hi students, let us have a discussion on rectifier circuits. The aim of this experiment are to observe waveform at the output of half and full wave rectifiers with and without capacitor filter, and to calculate ripple factor of the half and full wave rectifiers. Motivation to this experiment are: most of the electronic devices need DC signal for their operation. Rectifier circuits are used in power supplies, chargers, UPS and SMPS, etc. Let us understand the theory behind the experiment before conducting it. One of the very important applications of the diode is in DC power supply as a rectifier to convert AC into DC. Half wave rectification: when AC supply is applied at the input, only positive half cycle appears across the load, whereas the negative half cycle is suppressed. In full wave rectifier, there is a continuous current flow through the load resistor RL during both the half cycles and will get unidirectional current. Difference between full wave and half wave rectification is that a full wave rectifier allows unidirectional, that is one way, current to the load during the entire 360 degrees of the input signal, and half wave rectifier allows this only during one half cycle, that is 180 degrees. To conduct this experiment, we need step-down transformer of specification 606 or 909, resistor of 1 kilo ohm, diode models of 1N4007, capacitor of 100 microfarad, oscilloscope, breadboard, probes and connecting wires. Figure shows the circuit diagram of a half wave rectifier without filter with input and output waveforms. Experimental setup is made as per the circuit diagram. Input signal is provided by a step-down transformer. Connect the probes of an oscilloscope across the load resistor to see the output waveform and across the transformer secondary to see the input. Note down the peak value of the output waveform for further calculations. It shows the experimental result of half wave rectifier without filter. Figure shows the circuit diagram of a half wave rectifier with filter with input and output waveforms. Experimental setup is made as per the circuit diagram. Input signal is provided by a step-down transformer. Connect the probes of an oscilloscope across the load resistor to see the output waveform and across the transformer to see the input. Note down the peak value of the output waveform for further calculations. It shows the experimental setup as well as result of a half wave rectifier with filter. Figure shows the circuit diagram of a full wave rectifier without filter. Experimental setup is made as per the circuit diagram. Input signal is provided by a step-down transformer. Connect the probes of an oscilloscope across the load resistor to see the output waveform and across the transformer to see the input. Note down the peak value of the output waveform for further calculations. It shows the experimental result of half wave rectifier without filter. Figure shows the circuit diagram of a full wave rectifier with filter. Experimental setup is made as per the circuit diagram. Input signal is provided by a step-down transformer. Connect the probes of an oscilloscope across the load resistor to see the output waveform and across the transformer secondary to see the input. Note down the peak value of the output waveform for further calculations. It shows the experimental result of full wave rectifier filter.
Hello students, experiment name is half wave and full wave rectifier. Aim of the experiment is to observe the waveform at the output of a half wave and full wave rectifier with and without filter, and to calculate the ripple factor of a half wave and full wave rectifier with and without filter. Components used for the experiments are transformer. This is a transformer having a specification 909. It has primary side and secondary side. The primary side is connected to the 230 volt AC main supply, and secondary of the transformer is connected to the circuit. Digital oscilloscope, probes, capacitor with a value of 100 microfarad, diodes 2 in numbers, resistor having a value of 1 kilo ohm, breadboard and connecting wires. Let us start the circuit connection of a half wave rectifier without filter based on the given circuit diagram. Let us start the circuit connection. Start from the transformer. Transformer secondary has a 3 terminals. A black one is a center tap. We are not connecting this for half wave circuit, so I won't use this. And we have 2 terminals. They are the secondary terminals of a transformer. One terminal of secondary transformer is connected to the P side of a diode. I will take a diode, will connect in a breadboard. One terminal of the secondary transformer is connected to the P side of the diode. Another terminal of the transformer is connected to the ground. I will take first row of the bottom portion in a breadboard as a ground and connect it to ground. N side of a diode is connected to a 1 kilo ohm resistor. I will take a 1 kilo ohm resistor. One end is connected to a N terminal of a diode, and another end of resistor is connected to a ground. In a breadboard, this row is a ground line, so I will connect it to a ground. Now we will connect a oscilloscope to a circuit. Oscilloscope has 2 channels, channel 1 and channel 2. Channel 1 I will connect to a input, channel 2 I will connect to a output. Take a probe, will connect to a channel 1. This probe has 2 terminals, one is positive this end, another is negative this end. The positive terminal of this probe is connected to the input, that is one terminal of a secondary transformer, this point, connect here, and another terminal of, that is the negative terminal of the probe, is connected to a ground. So this I will connect to a ground. This is a ground line. Now I will take one more probe, which I will connect to channel 2. Again this has 2 terminals, one is positive, one is negative. According to the given circuit, the positive of the channel 2 is connected to the diode N side. This is the N side of a diode, and connect to the N side of a diode, and negative of the second probe is connected to the ground. I will take this negative and connect to a ground. This is a ground line, connect in a ground. Now we have finished the circuit connection for a half wave rectifier without filter. Once the connections are finished, turn on the digital oscilloscope. Wait for some time and connect primary of the transformer to a 230 volt main supply. Now turn on the power supply. Come to the digital oscilloscope. Again we will go here for a default setup, then auto set. Now we can see two signals in a digital oscilloscope display. One is yellow in color, one more is light blue in color. Yellow color is a signal from a channel 1 which is connected to a input. So yellow signal is a input signal and light blue signal is a channel 2 signal. Since we have connected channel 2 to the output, this light blue signal is a output. So I will turn off the input, and whatever signal we are seeing here, this is the output waveform for a half wave rectifier. I will move it up so that I can use the vertical position. By using vertical position knob, I am moving the signal up, and I will merge this pointer to a reference line in a display. Now this is the half wave rectifier output signal. I want to measure the peak voltage of this output waveform. So to measure this point peak voltage, I will move this peak value merge exactly to the reference line along the y axis. To do that, I will use a horizontal position knob and move the signal slightly left. Now I will measure a distance from this reference line to this peak point. If you see this display, it is covering one full block and two small division, that is 1.4 into 20. So 1.4 into 20 is equals to 28 volts. So I will note down this voltage as a Vm in a given tabular column. Now we will start the circuit connection for a half wave rectifier with capacitor filter. Already we have a circuit diagram for a half wave rectifier without filter. So just I will turn off the main power supply, remove the switch. So if you see the circuit diagram of a half wave rectifier with filter and without filter, there is a small variation. So without filter circuit diagram does not have a capacitor, with filter circuit has a capacitor. So for the same circuit I will connect a capacitor. So this is a capacitor which has two terminal, one is positive, one is negative. If you see the body of a capacitor, on the body of a capacitor, one side is a black strip, that end is given with a negative sign. This terminal is a negative terminal and another terminal is a positive terminal. According to the given circuit diagram, capacitor is connected to the load resistor. Sorry, capacitor is connected across the load resistor 1 kilo ohm. So I will take this capacitor and I will connect in parallel with the load resistor such that the negative of the capacitor should go to the ground line. So I will take this capacitor, I will connect somewhere in a breadboard. So this is the positive of capacitor and this is the negative of capacitor. To make a connection, I will take some connecting wires. Take a positive capacitor, connect to the resistor one end, and take one more connecting wire. I will connect this wire to a negative of the capacitor. This negative of the capacitor is connected to the resistor, another end are ground. Simply by connecting a capacitor to this circuit, now we have finished a circuit connection for a half wave rectifier with capacitor filter. Now connect a primary of the transformer to a 230 volt AC main supply and turn on the power switch. and already we have connected digital oscilloscope and we have given a default setup and data set. Now we can see the output waveform with capacitor filter on a oscilloscope display. So I want to measure output waveform peak voltage. If I want to stop this signal, just go to run or stop button here. Once you press run or stop, this signal will stop. So I want to note its peak voltage, so I will move this peak point to the reference line. I can do this by using horizontal position. I will use this knob and I will move signals towards left or right, so that this line will merge with the reference line. And I want to know what is the distance between this to this. So this is a zeroth line, it is covering one full block and two small division, that is 1.4 into 20 volt. 1.4 into 20 volt is 28 volt. This is the VM value for a half wave rectifier with capacitor filter. This value I will note down in a given tabular column. Now we have finished the half wave rectifier with filter and without filter circuit connections. We have observed the output waveform and also we have noted the output peak voltage. Let us begin with the circuit connection for a full wave rectifier without filter. Remove the complete circuit connections which we have done for a half wave rectifier. Now I will start a circuit connection for a full wave rectifier without filter. Again we will start a connection from the transformer. So this is a secondary of transformer. Here you have three terminals. The black one is center tap. This is also used for a full wave rectifier. According to the given circuit, one terminal of the transformer is connected to the diode P side. So I will take a diode, connect in a breadboard, and I will take another diode. This also I will connect in a breadboard. Let us call this as a diode 1 and this as a diode 2. The transformer secondary one terminal is connected to the diode 1 P terminal, and transformer secondary another terminal is connected to the diode 2 P terminal, and transformer's secondary center tap wire, which is black in color, is connected to a ground line. Let us take the bottom line first row as a ground line. This line I will connect to a ground. Next, according to the given circuit, N terminal of a diode 1 and N terminal of diode 2 are shorted. So I will take one small wire and I will short these two ends. So this is a N terminal of a diode 1, this is N terminal of diode 2. I will short these two, and this shorted point of a two diodes is connected to a resistor one end. So this is a 1 kilo ohm resistor. One terminal of this diode is connected to, this resistor is connected to the N terminal shorted end of a diode. So I am connect this one end of resistor to the shorted end of diode, and another terminal of the resistor is connected to the ground. So I will connect another terminal of resistor to a ground. Now we will connect a digital oscilloscope to the circuit. So this is a digital oscilloscope which has two channels, channel 1, channel 2. I will connect channel 1 to a input and I will connect channel 2 to a output. Let us take a probe. I will connect this to a channel 1. Again this has two ends, one is positive, one is negative. So the positive end is connected to any one terminal of the secondary transformer, either diode 1P or diode 2P. I will connect a diode 1P terminal, and this is the negative end of the channel 1 probe, which is connected to a ground. Now I have connected channel 1 probe to a input. I will take one more probe which is connected to channel 2, and I will connect this probe to a output. So, this is the channel 2 positive and this is the channel 2 negative. Since output is measured across the load resistor 1 kilo ohm, so I will connect a positive of the channel 2 probe to a resistor one end or the shorted end of a N terminal of a diode in a breadboard, and this is the negative terminal of the channel 2 probe which is connected to a ground. Now we have finished with the circuit connection of a full wave rectifier without filter. Once the connections have finished, turn on the digital oscilloscope and connect a transformer primary to a 230 volt main supply and turn on the power supply. Now go to default setup in a digital oscilloscope, then press auto set. Now you can see two waveforms in a digital oscilloscope display. One is input and one more is output. A signal which is yellow in color is a input signal, and signal which is light blue in color is a output signal or a output waveform. So I will turn off the output waveform by pressing button 1, and this is a output waveform. I will bring it to a reference line. I will move it up by using a vertical position knob, so that the pointer 2 will merge to this reference line. Now I want to know, or I want to measure the peak voltage or a maximum voltage of this signal. So to measure it, I will move this peak point on a reference line. This can be done by using a horizontal position knob. Either you move it left or right, so that you can bring a peak point of the waveform on a reference y axis line. If you see this waveform from this line, that is a 0 line, to this peak point, it is covering almost 1.3 division, one full and 0.3 small divisions. So 1.3 into 10, 1.3 into 10 volt equals to 13 volt. This is the output waveform peak voltage, that is Vm. So I will note down this value of Vm equals to 13 volt in a given tabular column. Now we have finished the circuit connection for a full wave rectifier without filter. Let us begin the circuit connection for a full wave rectifier with filter. This is a circuit connection for a full wave rectifier without filter. Turn off the power supply, remove the primary connection. Now I want to connect a full wave rectifier with filter. If you see the circuit diagram, simply by connecting a capacitor to a full wave rectifier without filter, it will become a circuit connection for a full wave rectifier with filter. So this is a capacitor which has two terminal, one is negative and another one is positive. I will connect this capacitor in a breadboard. If you connect a capacitor like this, this terminal is positive, this terminal is negative, and according to circuit diagram, the positive terminal of the capacitor is connected to the resistor one end. Take a wire, connect the positive terminal of a capacitor to the resistor one end in a breadboard, and negative terminal of a capacitor is connected to the another end of a resistor which is connected to ground. I will take one connecting wire and I will connect the negative terminal of a capacitor to the ground. So this is the ground line. Now we have finished the circuit connection for a full wave rectifier with capacitor filter. Once the connections are finished, connect primary of the transformer to a main supply, that is 230 volt AC, and turn on the power supply switch. Now we can see the output waveform in a oscilloscope, and again I want to measure a peak voltage of this waveform. So this is a zeroth line and this is a peak point. The distance from this line to this point is around 1.3, one full block and 0.3 small division. So 1.3 into 10 volt, 1.3 into 10 volt equals to 13 volt. I will note down this value in a given tabular column as a VM value. Now we have finished circuit connection for a full wave rectifier with capacitor filter. We have observed the waveform at the output of a rectifier with filter, and we have noted the output voltage peak value.
At MSR UAS, we spark your imagination unlike any other.